Hi, welcome back. So this is exactly where we left off. So in this video, we're going to see how to derive our T or topography. Now to do that, we have to bring in our DM data. So you can easily download DM data from USGS, or I already made a video on how to easily download DM data. You can check it here. So since we already have that data set available, let's locate our data over here, open up DEM. So let's sort this by type. We're going to use this particular one. Now we have another version projected, but we're going to assume we have it in the geographic degrees. So let's input this one. Let me simply change this. Now I'm going to clip this DM to our steady region. So the same way we go to raster, extraction, clip by max layer, DM is here, check our AOI. Now we're going to set it to projected system and we run. So we can go ahead and get rid of this. So now we have our clipped T here, but remember this is just the DM, or it's just measuring the vertical elevation. But what we are interested in when we talk about T is the slope of the area. So we need to change this into slope and then express it in percentages. Now, how do we do that? Let's select the layer and then we head to raster, go to analysis, and then select slope. So we ensure it is checked here since it's selected autofill. Then we are going to simply check this slope express as percent instead of degrees. Once you do that, we're going to click run and close. Now you can see it has changed from 89 to 588 to 0 up to 191. And you can see any area that has this gray color means the slope there is sharp or very steep, as opposed to the darker regions which are gentle. So what we're going to do now is save this because we need it. So I'm gonna export this and we are putting this in our T. So we simply call this slope, hit OK. Now is the best time to make the duplicate so that once we reclassify, we still have slope expressed as percentages. So we don't need to redo it. So let's duplicate this. Or if you like, you can go to the root folder and make the copy there. Keep it anytime you need it, just go get it. Anyway, so I'm actually going to keep this one and let's do the reclassing with the copied one. Now, the same show, we come over here, pick up our classify by table, click the ellipsis, open up this. What you can do here now is if we reference the table for slope or topography from 0 to 2, then 2 to 6, 6 to 12, 12 to 18, and then from 18 up. So we can use this because slope is expressed almost the same way across every geographical area. Slope is not the vertical measurement, it's measuring gradients. So no matter where this is applied, it's going to make sense, right? Even though it will affect how it is spread generally in the steady area. So I'm going to open up the table and let's restore this to keep it side by side. So now, once again, 5 of them. So we're starting off with 0. Then we go to here. Let's quickly get it in and then I'll explain. And then we have 18 T. Remember, we said you should get it over your max value. So we can put in here 192. Now, when it comes to the rating, we got values here. So we have 10, 8, 6, 4, and 2. The reason is that if you have this kind of range, it means the ground there is relatively flat. So that poses more risks. So we rate it high compared to over 18, which is tip 1. So we're giving it as low as 2. And now we click OK. And I'm going to save it to file inside of T. And we are going to call this TR. If you said that, you get it right, because this is our T rated. Now click run. And now it is done. So now we have our TR. How about we just multiply this by its natural rating and we'll be done with T as well. Now the natural rating for T, if you reference here, is 1. So among all of these parameters, T is treated to have less impact when it comes to combining all of them. Multiplying this by 1 gives us the same result. So we're just going to leave it like this, and we can actually rename this to TrTw. Very well. Just to make sense of this, you need to understand that your topography is not the same as your depth to water, even though both of them are basically working on the DEM. So you can see there's some kind of relationship. This is how we derive our T, and you can as well go ahead and start making your map with this as well. So that is it for topography. Let's check out the next parameter. See ya.